Okay, so this references the exploration that the book had you do, but I'll reference our little activity. Okay, so we basically figured out that the sum of the lengths of the two smaller sides of a triangle has to add to be greater than the third side. Okay, but that's actually true kind of in general. The sum of any two sides or side lengths of a triangle must be greater than the third side. Now, obviously, the one we normally would go to would be the two smaller sides, right? Because they're the smaller sides, and they have to add to be greater than the third side. Okay, but that's the idea here. So really, any of these inequalities must be true. So AB plus BC must be greater than AC, but also BC plus AC must be greater than AB, and AC plus AB must be greater than BC. But like Melissa correctly pointed out, really the important one we have to look for is the two smaller sides, and make sure they add to be greater than the third side, the greater side, or great S side. Okay, so if we look at the next page, all right, we have some examples. All right, so the example 1 here kind of shows us, or it says, use the triangle inequality theorem to tell whether a triangle can have sides with a given lengths. Explain. Okay, so the example we're given here is 4, 8, and 10. All right, so they say, all right, 4 plus 8, is that greater than 10? Yes. Okay, 4 plus 10, is that greater than 8? Yes. And then 8 plus 10, is that greater than the third side 4? Yes. Okay, so conclusion, the sum of each pair of side lengths is greater than the third length, so a triangle can have side lengths of 4, 8, and 10. Okay, now we look at the 7, 9, and 18, though. All right, and so here if we see that the 18 is in this box, that means what two sides must go in these two boxes? Anybody? So here we're looking at these 7, 9, and 18, so what must go in these two boxes? Anyone? Am I blocking it too much there?
7 and 9?
Well, so it's got to be 7 and 9, right? So then 7 plus 9 gives us 16. Okay, is 16 greater than 18? No. So we don't even need to do the rest of this because we already have a fail. Okay, once it fails once, it doesn't matter what the other ones do. Okay, so this triangle is impossible. Okay, because 7 plus 9 is less than 18. Okay, it fails the triangle inequality theorem. All right. So we look at the question like number 4 then. Can an isosceles triangle have these side lengths? 5, 5, and 10. Evan, what do you say?
Yes, because they're... No, never mind.
So never mind you don't want to answer, or never mind you don't want to say yes?
No, I think it's wrong.
You think it's so it's incorrect now?
Yeah.
Okay. So what makes it incorrect? I see two congruent sides here. That makes it isosceles, right?
Not greater than 10.
Right. So 5 plus 5, right, is not greater than 10. It's equal to 10. So no. Okay. 5 plus 5 is equal to 10, not greater than 10. Or something along those lines, right? So the triangle cannot exist. Okay? I don't know, 5 seems very straightforward to me. How do you know that the triangle inequality theorem applies to all equilateral triangles? It's like, I think that's kind of obvious, right? You're going to always, what's special about an equilateral triangle again? What makes an equilateral triangle equilateral? What's that mean? All the sides are equal, right? So if you have a triangle that's got 5, 5, 5 for its sides, then 5 plus 5 is greater than 5, right? The other two sides added together will always be greater than that third side. So I'm not going to bother writing that one down. That just seems kind of silly to me. 4 was kind of silly as well, but anyway. Okay, so real quick, 6 and 7, give them a shot. Tell me whether you think they are triangles or not. Okay, let's take a look there and see. Let me just take 2 seconds. Okay, are they or are they not triangles? Very good. Have fun. Okay. This is weird. Okay. So let's see here, Julia, number 6. What do you say?
No.
Nope. Okay. And so what? How does it fail?
Because 12 plus 4 equals 17. Wait.
12 plus 4 is not 17. 16, which is not greater than 17. Okay, so there you go. So yeah, so 12 plus 4 is greater than 17, so not a triangle. Or sorry, 12 plus 4 is less than 17, actually, right there, sorry. Okay, so that means it's not a triangle. Okay, number 7, let's go to Adam. What do you say? Number 7.
I said yes.
Yay or nay? Yay, you say, okay? So, how did you determine that?
24 plus 8 is 32, 32 is greater than 30.
Yep, so there we go. The two smaller sides are greater than the third side. Okay? So yes, that triangle could exist. Could exist. Okay? Alright, we are going to skip that next one there with the compound inequality stuff. Alright, but I do want to move on to page 345. Right here. Okay. And in addition to this whole idea of, the triangle inequality theorem, we also have something that's probably like intuitively just makes sense, but it does need to be stated because it's not a trivial matter, I guess. So, basically, we're just going to skip right down here to the side angle relationships in triangles, okay? So if two sides of a triangle are not congruent, then the larger angle is opposite the longer side, okay? So for example here, if we say that AC is greater in measure than BC, which is like visually we can kind of see that, so it kind of makes sense, right? Then it makes sense that the angle opposite AC, which is angle B, should be bigger than the angle opposite the BC, which is angle A. And that's true, right? Doesn't B look bigger than A in this picture here? And AC certainly looks bigger than BC. Okay? So, the longest side is always opposite the longest angle. The shortest side is always opposite the shortest angle. And the middle side is always opposite the middle angle. Okay? So, let's see here. If we flip that over, and look at page 346, and you can see that in play right here. Okay? You see we have the three sides of this triangle. So the longest side clearly is the AC because it's 15. Therefore, the greatest angle will be opposite that. So opposite AC, B. Okay? The shortest side is AB. Opposite that is 10, so that's our shortest angle. And so then in order, the angle measures from least to greatest would be C, then A, and then B. Okay? You got it. Okay, so letter B, go ahead and give that one a shot. Okay, based off the side measures there, come up with, fill in those blanks. Okay, fill in the blanks there. So Patrick, what's the longest side here in this picture? BC, you got it. Okay, and so therefore, Patrick, the greatest angle measure is going to be angle what? Very good, yep, angle A. Okay, thank you. Let's go to Stephanie. What's the shortest side length here? AB, you got it. And therefore, that means the smallest angle is going to be what? angle C. Good, and so then the order of the angle measures from least to greatest, okay, is going to be what there, Mary?
Measure of angle C, measure of angle B, measure of angle A.
Yep, angle C, the measure of angle C, the measure of angle B, I see what you're saying there, and the measure of angle A. Okay, that's right. Or if you just said angle C, angle B, angle A, that's okay as well. All right? All right, so that was for sides. If we were given sides, finding like the smallest angles and largest angles and the medium angles, right? But here, same thing is true for the angles to the sides. If you find the biggest angle, then opposite that would be the biggest side. Smallest angles opposite the smallest side, and the middle angles opposite the middle side. Okay, basically just summarizing that right there on the bottom, page 346. All right, we're not even going to bother doing some example problems here because I think you guys have got